Today in this video lecture, we will see numerical 8 on strain energy and impact. In this numerical, we will calculate strain energy. And strain energy for gradually applied load, suddenly applied load, and this impact load. This is equilateral triangle, all three sides are equal. 20 mm this side also 20 mm, and base is 20 mm. They have given us modulus of elasticity 200 GPa, and gradually applied load is 10 kN, suddenly applied load is 8 kN, and impact load is 4 kN, and length of that equilateral triangle is 600 mm. So we will see this numerical. First, see this case when pull of 10 kN is applied gradually. What is strain? Strain is denoted as U, and formula for strain is sigma square upon 2E. This sigma is stress, this E is modulus of elasticity, and multiply by area into length. So in this numerical we have this E also, this E is 200 GPa, this L also, L is 600 mm. We don't know this area and this stress, but we all know that area of triangle is half base into height. So area is equal to half base multiplied by height. Half base is 20 mm and height is basically this. We know this angle and this. So opposite side upon hypotenuse is sin theta. We use sin theta equation here. Sin theta is equal to opposite side upon hypotenuse. Opposite side let us denote as small h. So opposite side small h upon hypotenuse is 20 mm and angle is 60 degree. So sin 60 degree. Therefore this sin 60 multiplied by 20 is this h. So h is equal to sin of 60 degree multiplied by 20. So this area is 173.21 mm square. And also we all know that stress for gradually applied load is P by A, and P is this 10 kilonewton, and 10 into, that means 10 into 10 raised to 3 Newton upon area 173.21. So the stress is 57.73 Newton per mm square. So this one becomes, so U strain energy is equal to stress 57.73 square divided by 2 into, in numerical they have given us modulus of elasticity 200 GPa, that means 200 into 10 raised to 3 MPa. So 200 into 10 raised to 3 MPa multiplied by area is 173.21 and length is 600 mm. So this U strain energy 57.73 square multiplied by 173.21 multiplied by 600 divided by 2 into 200 into 10 raised to 3 865.89 Newton mm. And in Newton meter it is 0.86589 Newton meter, and Newton meter is nothing but the joule, 0.86589 joule. This is 9. Second case is 8 kilonewton load for suddenly applied load. So the strain energy is nothing but sigma square upon 2E multiplied by area into length. This area is same because triangle is same, 173.21. Length is also same, 600 mm. This stress is vary in suddenly applied load and gradually applied load. So the stress for suddenly applied load is 2 times P upon A. Is 2 multiplied by 8 into 10 raised to 3 divided by area is 173.21. So the stress 2 into 8 into 10 raised to 3 divided by 173.21 is 92.37 Newton per mm square. So this U is equal to 92.37 Newton per mm square. The stress square is 2 into 200 into 10 raised to 3 area is 173.21 and length is 600. Two two 16.79 Newton mm. That means 2.21679 Newton meter, and Newton meter is joule. Joule is unit of energy, heat. And the third term is for impact load. 4 kilonewton falls through 120 mm. Impact load strain energy is also denoted as U, stress square upon 2 into modulus of elasticity into area into length. But stress for impact load is different. Stress is W by A plus W by A square plus 2 modulus of elasticity, load and fallen height, that means this 120 mm is this small edge. From that height, this triangular type material impact on this collar. That means this collar impact on this material to 120 mm height. And divided by area into length. So this stress is equal to, the load is this 4 kilonewton, so 4 into 10 raised to 3 newton divided by area is 173.21. E modulus of elasticity is 200 into 10 raised to 3. Multiply by again W, 4 into 10 raised to 3, and multiply by H is 120 mm. And area is 173.21. Length is 600. So the stress is equal to 23.09. So the stress is 1382.50 and unit is Newton per mm square. See one difference between gradually applied load, suddenly applied load, and impact load. See, I will show you difference. For gradually applied load, it is 10 kilonewton, and see the stress is 57.73 Newton per mm square. And for suddenly applied load, it is 8 kilonewton. That means less than this gradually applied load. Even though this is less than gradually applied load, but stress comes more than gradually applied load. See stress difference. Stress for this gradually applied load is 57.73. Okay, I will write here for clarification. For gradually applied load, for suddenly applied load, and for impact load. First see stress. load are 10 kilonewton, 8 kilonewton and 4 kilonewton. Ten kilonewton load and 4 kilonewton load. So the stress for 10 kilonewton load is 57.73 Newton per mm square. The stress for suddenly applied load comes 92.37. And stress for impact load is 1382.50. Now see this 10 kilonewton and this 57.73 kilonewton. Even though gradually applied load is bigger than the suddenly applied load and impact load, stress is minimum than suddenly applied load and impact load. This suddenly applied load is 8 kilonewton and stress is 92.37 maximum than this gradually applied load. And this impact load is very less from suddenly applied load and gradually applied load. It is half of gradually applied load and half of suddenly applied load, and it is more than half of gradually applied load, and stress is maximum than both of these. So see, this is difference between this. For impact load, even if this P load is minimum, the stress comes maximum, and for gradually applied load, even though this load is maximum, their stress comes minimum. So this is difference between gradually, suddenly and impact. And strain energy for impact load is U is equal to 1382.50 square divided by 2 into modulus of elasticity is 200 into 10 raised to 3 multiplied by area is 173.21 and length is 600. 1382.50 square multiplied by 173.21 multiplied by 600 divided by 2 into 200 into 10 raised to 3 is 496.586 Newton mm and into 10 raised to 3 here. That means this is 496.586 Newton meter, 496.586 joule. Compare strain energy also for impact load, suddenly applied load and gradually applied load. 0.865 joule. .21 joule. You see, For impact load, strain energy is also maximum. For suddenly applied load, strain energy is 2.21 joule, and gradually applied load it is 0.865 joule. So for impact load, it is maximum value of strain energy compared to suddenly applied load and gradually applied load. And suddenly applied load, strain energy is 2.21, gradually applied it is 0.86 joule. So similar behavior seen here as stress, similar to stress behavior, strain energy also behave for gradually, suddenly and impact load. See this range is also maximum 57, 92, 1382 is gradually increasing this value, and this value is also increasing. So this way our numerical completes. Thank you very much.